Chapter 3, Mass Relationships and Chemical Reactions. But before we get started, we have Chemistry Cat. What do you do with a dead chemist? You bury him. Chemical equations. A chemical equation describes a chemical change. It needs the following in order for a successful chemical equation to be written. You need, first, your reactants and products. Where are the reactants located in this equation? It is on the left side. So these are the reactants, and we can think of it as what is being reacted. So methane, gas, plus 2 oxygen molecules, which are gas, are reacted, and then they produce our products. So the products are what's being produced. So we get carbon dioxide and 2 water molecules. The second thing we need are the symbols. These are used to indicate the state of the chemical that it is in. So for example, methane. Methane is a gas, and so we can write G for gas. L for liquid, S for solid, and AQ means aqueous. Aqueous means dissolved in water. So AQ stands for aqua, and so you can think of it as water. Most of our chemicals that we deal with involve the aqueous state, and we're going to talk a lot more about this later on. The other thing is that necessary conditions are written above the arrow. Sometimes we'll see it in this class, but more often than not, if you take organic chemistry, you will see it all the time. So for example, you would have heat if you needed some heat in order for the reaction to occur. Some other things that we need to think about when we're doing chemical equations is the law of conservation of mass. Okay, who came up with this law? It was that French guy, Antoine Lavoisier. Okay, and it states that matter can never be created nor destroyed in a chemical reaction. So how does this relate to a chemical equation? Well, it means that the equation must be balanced. So you have to have equal number of atoms on the left as equal number of atoms on the right. So the numbers and kinds of atoms must be the same on both sides of the reaction arrow. Okay, so now we have a subscript. We have a subscript, and we can also have a superscript. A subscript is the smaller number on the bottom, and it tells how many atoms of each of an element are in a molecule. So what is the subscript for H2O? 2. 2 is our subscript. So that tells us that we have 2 atoms of hydrogen. What would be the subscript for oxygen? Well, they don't write a 1, but it's assumed. So how many atoms of oxygen do I have? Just 1. Remember, you never write 1 as a subscript. It's assumed. Okay, and then the other thing we can have is a coefficient. The coefficient is the number out in front, and it tells us how many total molecules there are. So if I have 2 H2O, what is the coefficient? The coefficient is the number out in front, so it's going to be this 2. So that means that we have 2 water molecules. Now, just for fun, if I have 2 water molecules, how many hydrogens would I have? Okay, well, think of it this way. If you have 2 H2Os, let's say you have one there, and another one here, right? You have 2 of them. So how many hydrogens are there? 2 plus 2, so that's 4 hydrogens. Now, if you don't want to write it out, what you can do is you can say 2 for the coefficient times the subscript, which is 2. Okay, now for oxygen, how many oxygens are there? There would be 2, because you take the coefficient, 2, times the subscript, which is 1. How many atoms of each element are there in the following molecules? Let's do a few of these. Okay, C6H12O6, this is a sugar molecule. How many carbons are there? 6. So 6 carbons. How many hydrogens? 12. And how many oxygens? 6. Okay, let's do this one. This one's a little bit more challenging. All right, okay, so the first molecule is calcium, so let's figure out how many calciums there are. Okay, what is the subscript for calcium? I only have 1. So how many total calciums are there? There's only 2 of them. 2 times 1. Okay, now what gets tricky is our polyatomic NO3. Okay, so if I block off the coefficient, so let's say I don't look at this 2 yet. How many NO3s are there? There's 2 NO3s. So what I can do is I can kind of go through and just multiply through the parentheses. So instead of 3 oxygens, I can say now that there's 6, right? Because of that 2. Okay, now going through, how many nitrogens are there? There's 4, because it's going to be 2 times 2. And then how many oxygens are there? There's 6. 2 times 6. Oopsie. I did that wrong. How many oxygens should there be? There should be a total of 12. Okay, I want you to go through and I want you to fill in how many atoms of each element there are in these different molecules. With chemistry, a big part of it is looking at equations, because equations tell us the recipe in order to make something. In order for an equation to be correct, we need to make sure it's balanced. So here are some rules that describe how to make something balanced. The first one is you can only change the coefficients. What are coefficients? These are the numbers out in front. Okay, one thing you cannot change are the subscripts. These are the numbers that are on the lower right. Second thing is the numbers and kinds of atoms must be the same on both sides of the reaction arrow. We can reduce coefficients if needed. For example, if you have 2 hydrogens on the left and 2 hydrogens on the right, you can reduce that. So here are some tips. You balance the big formulas first. Save lone elements for last, as well as hydrogen and oxygens. Now you don't have to follow this rule or this tip, but it's really going to help you when we're balancing equations. So balance the big things first. Leave hydrogen and oxygens as well as lone elements last. If the same polyatomic ion appears on both sides of the equation, it's usually okay to treat it as one unit. And lastly, some are just plain tough and you need time and creativity to solve it. So let's try some examples. Practice balancing an equation. I'm going to show you two ways you can balance it. The first way is the longer way, but it helps you kind of see where things are coming from. Option 1 uses a table to keep track of the atoms. Okay. So each column represents a molecule. And on the far left column, we have our atoms. So in this equation, all we have are nitrogens and hydrogens. So before we even get started with the problem, let's fill in these different columns. For nitrogen, on the left one, for the reactants, how many nitrogens are there? We have 2. Do we have any hydrogens? Nope, so we can just leave that blank or put an X through it. We don't have to look at that. Okay, now for hydrogens that are still a reactant, how many hydrogens are there? 2. And we have no nitrogens. For NH3, how many nitrogens do we have? Only 1. And for hydrogens, how many other? 3. Now our goal is we need to get the stuff on the left, which are our reactants. We have to get that equal to our things on the right, which are our products. So that means our nitrogens, they have to be the same amount. Right now, are they the same amount? No, because on the left we have 2, and on the right we only have 1. All right, and then our hydrogens also have to be the same. We have to get them to be equal. Right now they're not, but our goal is we have to get them to be equal. Okay, so the only thing we can do to an equation is we can only change the coefficients. I'm going to abbreviate it as COEFF for coefficients. So that means we can change the number out in front. We cannot change the subscripts. So like this 2 here is a subscript. We cannot touch that at all. So no touchy. Alright, so let's change these coefficients. Let's look at nitrogen for our first example. On the left we have 2 nitrogens. On the right we have 1. Okay, so that means the smaller amount, which is 1, we have to put a number out in front to get 2 nitrogens. What times 1 equals 2? A 2. Okay, so now if we add a coefficient, we're going to go through and change our numbers. So instead of 1 nitrogen, how many nitrogens do I now have? 2. Instead of 3 hydrogens, how many do I now have? 6. Because 2 times 3 will be 6. Okay, so our nitrogens are happy, 2 and 2 on the right, but our hydrogens are not happy. So let's look and balance hydrogen. So on the left side, I'm going to put a coefficient in front of this H2. What coefficient should I put it out in front? What times 2 will equal 6? 3. Alright, so let's go through and change it. Instead of 2 hydrogens, now I will have a total of 6. Okay, now is everything balanced? Yeah, because I have 2 nitrogens on the left, 2 nitrogens on the right, so we're good there. For hydrogens, we have 6 on the left, 6 on the right, so we're good there. This is the longer way of doing it, but it really helps you to keep track of your different atoms. Option 2 is, if you are comfortable, use trial and error. If you get really fast, then you can start using this method. So let's try it. Okay, so what I would notice first is, balance your nitrogens first and then save your hydrogens and oxygens for last. So nitrogens, I have 2 on the left and only 1 on the right. So I'm going to put a 2 over on the right side so that I get 2 nitrogens. Alright, now if I put a 2 out in front of NH3, that gives me 6 hydrogens. 2 times 3. So then I look over on the hydrogens on the left side. I see that I only have 2. So in order to get 6, I'm going to put a 3 out in front. Okay, so I can go back and check my work. I have 2 nitrogens here, 2 nitrogens. So far that's good. We have 6 hydrogens on the left, and we also have 6 hydrogens on the right. So we know we did it right. Option 2 is a lot faster, but if you're new to balancing equations, if you've never done it before, I highly recommend doing the table setup. Let's do a harder problem. Okay, so here's our table. We have our molecules already in there, but now we have to add our elements on the left side. Okay, so the first element that I see is I have an aluminum. So I'm just going to write aluminum here. And let's go and fill in all of the different aluminums. How many aluminums are in that first molecule? Aluminum hydroxide. I only have 1. Okay, because that 3 represents I have 3 OHs. I don't have 3 aluminums, I only have 3 OHs. So only 1 aluminum. For H2SO4, I don't have anything. Al2SO4 and 3 of those. That means I have 2 aluminums. And no aluminums for water. Okay, then my next element. Well, I would see I have an oxygen or I have a polyatomic. Should I write oxygen or OH? Because if you go back in the notes, a polyatomic, a lot of times you can think of it as a unit. You can think of it as combining them together. Well, when you do this, because the polyatomic OH does not appear on both sides, so I only have an OH on the left, I have no OH on the right, we treat each atom separately. So that means I have an oxygen and I have a hydrogen. I don't think of it as an OH. And it's simply because they're not found on either side. So let's go through and look at our oxygens and hydrogens. For the first one, how many oxygens are there? 3. Second one? 4. Third molecule? 12, because 4 times 3 is 12. And water? 1. Okay, now for hydrogens, for the first molecule, how many are there? 3, because 3 times 1 will be 3. Second one, 2. Third one, well, I don't have anything there, no hydrogens. And for H2O, 2. Alright, so far I have aluminum, oxygen, and hydrogen. What other atom or polyatomic do I not have? Okay, now I have a second polyatomic. I have SO4. So the polyatomics I have in this equation are OH and SO4. Polyatomics, those are coming from that table that we looked at in chapter 2. Okay, so for SO4, can I treat it as SO4, or should I think of it as sulfur and oxygen? Since the polyatomic ion SO4 appears on both sides, we treat it as one unit. So we don't think of it as sulfur and oxygen. And that actually makes life a lot easier for us. We think of SO4 as one unit. So for the first molecule, aluminum hydroxide, we don't have any SO4s. For the second molecule, H2SO4, how many SO4s do I have? I will only have one unit of SO4. Okay, now for this one, the third molecule, how many SO4s do I have? I will have a total of 3 because of that subscript 3. Okay, and then for water, how many SO4s? None, so I don't have to look at it. Okay, so and remember we have to get our reactants to equal our products. What are our reactants? The two on the left. What are our products? The ones on the right. And this is going because of this arrow. So our goal is to get reactants and products to equal each other. Alright, so what we do is we look at our bigger molecules first and save our oxygens and hydrogens for last. So let's look at aluminum first. And that's basically just a hint. It helps you when you're doing these equations. How would I balance aluminum? Because I only have one aluminum on the left and 2 on the right, I'm going to put a 2 out in front. If I put a 2 out in front, that gives me now 2 aluminums. But now that also will change my other answers. Instead of 3 oxygens, how many oxygens will I now have? 6, because 2 times 3 will be 6. Basically, you're just multiplying this entire column by 2. So 2 times 3 will be 6. Okay, so our aluminums look good. What is the next thing we should balance? Okay, I would say the oxygens and hydrogens for last. And so then look at your other molecule, which would be our polyatomic, SO4. So SO4 on the left, we have 1, and SO4 on the right, we have 3. So how would I balance that out? I would put a 3 out in front. Okay, so that means I'm going to multiply this entire column by 3. 3 times 4 would be 12. 3 times 2 is 6. 3 times 1 is 3. Alright, so that looks like our sulfates, SO4, are balanced. 3 on the left, 3 on the right. Now comes more of the tricky part, which is aluminum and hydrogen. What should I balance first? It's not really going to matter too terribly much, but let's say we're going to balance hydrogen. And this is where you kind of have to just play around with it. Now, our hydrogens, how many hydrogens are on the left side? Well, I have 6 and 6, right? So I have a total of 12 hydrogens on the left. Now, the one on the right, I only have 2 of them, right? So what coefficient should I put out in front of water to make 12? Okay, I would have to do a 6 because 6 times 2 would be 12. So now let's balance that out. Instead of 1 oxygen, I now have 6 oxygens. Instead of two hydrogens, I now have 12. Okay, so that looks like our hydrogens are now equal, 12 on the left, 12 on the right. And let's look at our oxygens. Let's see if that needs to be balanced. How many oxygens are on the left side? Okay, I add them up. So that means I have 6 plus 12. That's 18 oxygens, whoops. 18 oxygens on the left. How many oxygens would be on the right side? 18. So that's good. Now the last thing I want to do is just double check to make sure everything is balanced. 2 aluminums on the left, 2 aluminums on the right. So we're good there. Oxygen, 18 left, 18 right. So we're good. Hydrogens, 12 on the left, 12 on the right. Good. And sulfate, 3 on the left, 3 on the right. So good. Awesome. So we know we did it right. So now let's get some practice with balancing chemical equations. We're going to do a few of these, but then you're going to do the rest of them. Let's do the first one together. The one on the left, or which element should I balance first, magnesium or oxygen? Remember, you balance the bigger ones first. So you want to balance magnesium. How many magnesiums are on the left side? Just 1. And how many on the right? Just 1. Okay, now let's look at our oxygens. How many oxygens are on the left side? 2. How many are on the right side? 1. So obviously that's not balanced, 2 versus 1, so we have to make sure that's balanced. How would we do that? We would have to put a coefficient out in front, so we would put a 2 there. Okay, so now that causes our magnesiums to be off-kiltered. So instead of 1 magnesium, I now have a total of 2 of them. Instead of 1 oxygen, I have 2. So our oxygens are balanced, but our magnesiums aren't. So we have to go back through and balance that. So how would I make magnesium balanced? I would have to put a coefficient out in front. What coefficient would that be? A 2. So now I will have 2 magnesiums. Are we balanced? Yeah, because I have 2 magnesiums on the left, 2 on the right, 2 oxygens on the left, 2 oxygens on the right. So it would be balanced. Now I have a question. What if I had this? Is this balanced? Yeah, it would be balanced because I have 4 magnesiums on the left, 4 on the right, 4 oxygens on the left, 4 oxygens on the right. But this would be considered wrong if you had this. The reason why is because you need to reduce to the smallest whole number. Yeah, reduce to the smallest whole number. What is smaller than, or what can I reduce 4 to and 4 to? Well, I could divide everything by 2, right? So I'd have 2 of those, just 1 oxygen, and 2 magnesiums. But because I have 1 oxygen, I don't need to write it. So really, it should always get reduced to our smallest whole number ratio, 2, 1, and 2. And let's look at the last one. I have aluminum nitrate plus sulfuric acid, H2SO4, produces nitric acid, HNO3, plus aluminum sulfate. What is the first thing I should balance? Well, the only thing I need to worry about is leave hydrogens and oxygens to the very end. So I see aluminum first, so let's balance that one. How many aluminums are on the left side? Only 1. And on the right side, how many aluminums are there? 2 aluminums. So to balance that out, I would put a 2 out in front. So now I get 2. Okay, and then I have hydrogens, oxygens, nitrogens, and sulfurs. But remember, I have polyatomics. What are the 2 polyatomics I have? I have NO3. I have 1 on the left and 1 on the right. I also have SO4, 1 on the left, 1 on the right. Okay, so therefore I'm going to think of them as one unit. I'm not going to think of them as nitrogens and oxygens. I think of them as just an NO3. So let's say I'm going to look at NO3 next. How many NO3s are on the left side? I have 6 of them. The reason why is because you take the coefficient times the subscript, which is 3. How many NO3s are on the right side? Only 1. Okay, so to get that balanced, I would multiply by 6. So now I have 6 NO3s. So that's balanced. Now let's look at our SO4s. How many SO4s do I have on the left? 1. And how many SO4s do I have on the right side? 3. Okay, so we need to get that balanced. What must I do? Multiply this one by 3. So now I get 3 SO4s. Then the last thing is you want to look at your hydrogens. Make sure that's balanced. How many hydrogens are on the left side? I have 6 H's. And on the right side, how many do I have? 6 as well. Okay, so we can just go through, balance everything real fast, make sure everything is good. 2 aluminums on the left, 2 aluminums on the right. 6 NO3s on the left, 6 NO3s on the right. 3 SO4s on the left, 3 on the right. 6 hydrogens on the left, 6 hydrogens on the right. Okay, so therefore we can say we know we did it right. Oh, and the other thing we want to just double check is, can we reduce? You always want to ask that question at the very end. So can you reduce 2, 3, 6, and 1? Nope, you can't. If you divide by anything, you're going to get a fraction. So this will be the smallest whole number that you can have. Let's get some more practicing with chemical equations, because these are usually what causes some problems when we're doing this chapter. Okay, I want you to do the first 3, but let's do the last one together. Okay, so for the last one, what is one thing that you would balance first? Okay, I would want you to balance carbon first because remember you leave oxygens and hydrogens for the very last. So on the left I have 4 carbons. On the right I only have 1. So that means I must put a 4 out in front to get 4 carbons. Okay, now what you need to do is balance oxygens and hydrogens next. It's really a gamble which one is going to be easier. I'm going to say let's do hydrogens next, but remember it's just a gamble. Okay, so let's do hydrogens. On the left, I have a total of 10. On the right, I have a total of 2. So what coefficient should I put out in front to make 10? I would need to put a 5 out in front. 5 times 2 will be 10. Okay, so carbons, hydrogens, those are balanced. Now comes the really challenging one, oxygen. On the left side, I have 2 oxygens. On the right side, just going to draw my line here, I have 8 oxygens plus another 5 oxygens, so that gives me a total of 13 O's. When you have odds, this is where it gets challenging. My recommendation is I do a cheat way of doing it. So that means I need to get oxygens on the left to be equal to 13. That's my goal. But how in the world can I, if I have 2, what times 2 will equal 13? It's not a whole number. It's a fraction. Okay, so I'm going to cheat. I'm going to use a fraction, but that's not my final answer. So 13 divided by 2 times 2 will give me 13. Okay. Now, because I cannot have fractions in there, I must multiply in order to get rid of that fraction. Now, let me go back. If I go back through and I balance everything else is balanced, right? I have 4 carbons on the left, 4 carbons on the right, 10 hydrogens on the left, 10 on the right, and then my oxygens. That's the only problem because I have a fraction. So because everything is balanced, I'm going to go through and I'm going to get rid of that fraction. How do I get rid of that fraction? I multiply it by 2. But because I multiplied that by 2, I have to multiply everything by 2. 2 times this entire thing. So that means I'm going to have 2 C4H10s. How many O2s? 13. 8 CO2s. And 10 waters. Okay, now this is going to be my equation, my balance equation. Now, the other thing is, can I reduce these anymore? Can I reduce 2, 13, 8, and 10? Nope, this is the smallest ratio that I can have. So this would be my answer. And to finish off balancing chemical equations, we have Chemistry Cat. It's coming from the Forrest Gump line. Life is like a box of compounds. Things always balance out.